X equals sine t, y equals 2 cos t minus t. We want to plot it between this range here, t between minus pi over 2 and pi over 2. And we want to find the turning points and investigate their nature. So here, let's get dx dt and dy dt first then, as is customary. Sine differentiates to cosine, dy dt. Cosine goes to minus sine, and there's two lots of. T goes to 1, and there's a minus in front. So, dy dx then is equal to dy dt. Now there's a minus at the front, so I'm going to pull that out and write 1 plus 2 sine t, like so, over dx dt. Cosine t equals 0. Well, it's going to equal 0 when sine t, and we need the value minus a half in here, don't we, for that bracket to equal 0. So it's minus a half. If you remember the CAST for the trig functions, to get the value of t, CAST, we're only interested in this side here from minus pi over 2 to pi over 2. Sine is negative in this quadrant, so the associated acute angle will be pi over 6. So the angle is going to be minus pi over 6. So t equals minus pi over 6, or minus 30 degrees. So that's what we've got then for our value of t. So we need to look at dy dx and get the value as well of the turning point at t equals minus pi over 6 then. What's our coordinate? xy is equal to sine of that, which we just said was minus a half, and the y value, cos is root 3 over 2, so this will be root 3 minus t, which is minus pi over 6, so it's plus pi over 6. There we go. So there's our turning point then. Now, is it a max or min? Well, let's have a look at the gradient function here. Dy dx is equal to minus 1 plus 2 sine t, let's just write it out again, over the cosine t. Now, let's just have a look at it. T is slightly less than pi over 6, minus pi over 6 that is. We need to look at that side, and we'll look at t as slightly greater than minus pi over 6 and see what we get. We know that at minus pi over 6 this will be a half, and this will make this 0. So the sine function then, let's have a look at the value of the sine. In this quadrant, I'm going to draw the sine now as a sketch. The sine goes like this, doesn't it? And like so. We're dealing with a value here, so this value of sine will be negative, and it will be negative. It will actually equal a half on this side. This term here will be bigger than minus 1. And if it's bigger than minus 1, this will be negative, this whole thing. And that will make it positive. So we got positive over, and the cosine of this is positive, isn't it? Because it's a positive quadrant. So we got positive there. So let's put that in, it's positive. Now what about this side? When t is this side of the minus pi over 6, the sine is slightly less than the half, even though it's negative. So 1 plus that value will be positive. So because we've got a minus outside, that will be negative over a positive, because cosine is positive in that quadrant. Negative over a positive is a negative. So as t increases through the value minus pi over 6, we go from positive to negative in terms of dy dx. Now, the only other thing to worry about is cos, is the x value. X is equal to sine t. So let's have a look at that. So here's the sine t function. As t increases here, you can see what happens to sine t. It increases here. Now, as t increases through the value minus pi over 6, x increases in value. So that's good. So we can read this off in the correct orientation. So it goes from positive on the left to a negative on the right. So we have a maximum. So we have a max, turning point at, and the point was minus a half, and then it's root 3 plus pi over 6. 1.7 pi over 6 is a half. It's just over 2 here. So let's just check that with our sketch. We're going to type in this first and then we'll scroll down after. Sine t 2 cos t minus t. Let's tap that in. Sine t 2 cos t minus t. Sine t and then 2 cos t minus t. Okay, and we're going from, what was it, minus pi over 2 to pi over 2. Let's plot that. See what we get. Here's our maximum here, minus half, and just over 2 as we said. That's what we've got. Just over 2 we said, didn't we? And it was a maximum, which is what we said.